Hi everyone, welcome to you all. Today let us discuss about Aldol condensation. So what do you mean by Aldol condensation? Under the influence of dilute acid or dilute alkali, two molecules of aldehyde or ketone, it may be an aldehyde or it may be a ketone, may combine to form beta hydroxy ketone. So you can, if you use aldehyde, you'll get the product as beta hydroxy aldehyde. If you use the ketone, you'll get the product as beta hydroxy ketone. This reaction is called as aldol condensation. I repeat again. So under the influence of dilute acid or dilute alkali, two molecules of either aldehyde or ketone may combine to form beta hydroxyaldehyde or beta hydroxy ketone. This reaction is called as aldol condensation. So in every case, the product, so you may take every case means in the case of either aldehyde or it in the case of maybe a ketone. So the addition of one molecule of aldehyde or ketone to a second molecule in such a way that alpha carbon of the first becomes attached to the carbonyl carbon of the second one. So you are taking similar type of aldehydes or similar type of ketones. So the first molecule of either aldehyde or ketone is going to attach to the second molecule in such a way that the alpha carbon of the first is going to become attached to the carbonyl carbon of the second. Here I have taken an example of acetaldehyde. 2 moles of acetaldehyde reacts to form beta hydroxy butyraldehyde, which is otherwise called as 3-hydroxy butanol. So mainly we are seeing one base here, that is hydroxide ion. This hydroxide ion is main thing which is used to produce carbanion, which is an actual nucleophilic reagent. So the purpose of hydroxide ion used in this reaction is to produce a carbanion, which is the main nucleophilic reagent. Its use can be detailedly explained in the mechanism of aldol condensation. If aldehydes or ketones does not contain alpha hydrogen, a simple aldol cannot take place. So remember the point, if either aldehydes or ketones, if they does not contain any alpha hydrogen in their structure, therefore, it is not going to give you an aldol product. You can see the structure also. Different aldehydes we have used, aromatic aldehyde, formaldehyde, that is aromatic aldehyde is nothing but benzaldehyde, like that, so on examples. So in the case of aldehydes and ketones, a functional group is a carbonyl group. The functional group is responsible for the formation of alpha hydrogen. The hydrogen present on the alpha carbon is nothing but the alpha hydrogen, and it is basically slightly acidic in nature due to the carbonyl group and its resonance stabilized mechanism. Whatever the alpha hydrogen is present in the structure is usually slightly acidic in nature due to the presence of the carbonyl group and its resonance stabilization mechanism. I again point out in you the main point here, the carbonyl compounds which does not contain alpha hydrogen atom failed to show the aldol condensation. They does not give aldol condensation. For example, you can take formaldehyde, benzaldehyde, trimethylacetaldehyde, etc. These all things do not show aldol condensation. Aldol condensation is seen only in the case of the alpha hydrogen is present in the structure, because that alpha hydrogen, you can see in the previous slide also, the alpha carbon of the first becomes attached to the carbonyl carbon. That means the alpha carbon of the first molecule is going to attach to the carbonyl carbon of the second. So without alpha hydrogen there is no aldol condensation. Next, let us see the mechanism. So what is exact mechanism involved in the aldol condensation is, the first step includes hydroxide ion abstracts a hydrogen ion from the alpha carbon of the aldehyde to form carbanion. If you see the acetaldehyde structure, 1 mole of acetaldehyde is used here. So that is OH is abstracting from CH3 group to form H2O, and the remaining portion is CH2CHO, which is nothing but a carbanion. So generation of carbanion is the first step. And in the second step, the formed carbanion will attack the carbonyl carbon of the second aldehyde to form ion 2. So in the second step, what you are seeing, you are using another mole of acetaldehyde. First 1 mole we have used it in the first step for the generation of carbanion, and in the second step the carbanion is attacking to the carbonyl carbon of the another mole of acetaldehyde to form an alkoxide ion, to form a alkoxide ion. So here only if you keep H in the beside O, then our product will be the aldol. So for that, the alkoxide ion, whatever it is formed, it is going to abstract a hydrogen ion from water. It is going to abstract a hydrogen ion from water to form beta hydroxyaldehyde, regenerating the hydroxide ion. So in the third step, alkoxide ion is going to abstract a hydrogen ion from the water to generate aldol, and regeneration of hydroxide ion takes place. This regeneration of hydroxide ion is again going to react with 1 mole of acetaldehyde to form a carbanion, and continuation of the reaction takes place. And these are the applications in the aldol condensation. So whenever excess of formaldehyde is condensed with acetaldehyde, so here you are treating formaldehyde with acetaldehyde, in aqueous solution of calcium hydroxide, trihydroxyaldehyde is formed. So there is a formation of trihydroxyaldehyde. There is a formation of trihydroxyaldehyde which undergoes crossed Cannizzaro reaction with formaldehyde to form pentaerythritol. So this pentaerythritol is required for the production of explosives. Pentaerythritol is required for the production of explosives. So here we have used two different types of aldehydes for the reaction, which comes where you are reacting with a base calcium hydroxide with aldol condensation type of reaction to form trihydroxyaldehyde, to form a trihydroxyaldehyde. So here that's why the reaction has not stopped at the trihydroxyaldehyde. Again it continued with Cannizzaro reaction, that is crossed Cannizzaro reaction, to form the final product, to form the final product. So this completes the aldol condensation.